Okay, so at the top of our keynote, it says complete number 1 through 7 on page 53 through 55 for homework. So because it's Monday, we don't have live meets. This is a pre-recorded lesson. So we're going to start. We're identifying opposites and absolute value of rational numbers. So positive and negative rational numbers. Water levels with respect to sea level, which has elevation 0, may be measured at beach tidal basins. Water levels below sea level are represented by negative numbers. The table shows the water level at a tidal basin at different times during a day. Graph the level for each time on the number line. So, the time is 4 a.m., which is A. It is a positive 3.5. So, in order to graph that, first we need to put the plus sign and draw. Again, if you have the textbook, you can just do this directly in the textbook. So, we see 3.5. So, we go from 0 and we count over 1, 2, 3. And then we go in halfway between 3 and 4. That is 3.5. Because the decimal 0.5 equals 1/2. So that is A. So I'm going to draw or write A on top. Then B is a positive 2.5. So we're going to start at 0 and go right 2. And it's going to be right in the middle of 2 and 3. Again, my 0.5 decimal is the same as 1/2. C is negative 0.5. So since it's negative, we go left. So we start at 0 and we just go halfway between 0 and 1. So you plot your point right there and you label it as C. D is negative 2.5, so you go left to the 2, and in between the 2 and the 3 is negative 2.5. And then E is a positive 0.5. So you're going right from 0 only halfway between 0 and 1. And that is E. How did you know where to graph negative 0.5? We went left because it was negative, and we went only halfway because 0.5 equals 1/2. So I'm going to write negative equals left. 0.5 equals 1/2. So it's in between the 0 and the 1. The 0 and the negative 1, I'm sorry. At what time or times is the sea level closest to sea level? Do you guys remember what sea level is? It says it up here. Sea level, which is elevation of 0. So which numbers are closest to 0 on our number line? So if we look, I can highlight the 0. Which points are the closest to sea level? So C and E, which is noon. I see that right here above C, and 8 a.m. Because it said at what time. It didn't say what number, what letter. It said what time. Which point is located halfway between negative 3 and negative 2? So I'm going to find my negative 3, my negative 2. What number falls in between those two? D. Which point is the same distance from 0 as D? So 0 we're going to count 1, 2.5 from 0. So we need to do it the other way. 1, 2.5. What point is that? It is point B. So number 1, this is your first problem for homework. How would you graph negative 2.25? Would it be left or right of point D? So first we can answer, would it be left or right? Look at the sign. If it's positive, it goes right. If it's negative, it goes left. And we see the little tiny minus sign. So it would go left. You would go only 1/4 past the negative 2. 0.25 is the same fraction as 1/4 because it equals 25 over 100 when you graph it as a decimal, and that can be simplified all the way down by dividing the top and the bottom by both 25. 25 divided by 25 is 1, and 100 divided by 25 is 4. So it would be negative 2 1/4 places left of 0. And then I'm going to draw a little diagram for you. So if I have negative 3, negative 2, negative 1, and 0, I would go 1, 2, and then I know that the half mark is right here, so it's going to be right here. It's going to be only 1/4. That would be point D. So I'm going to write a little D on top of it. I hope that helps you with number 1. Now let's look. Rational numbers and opposites on a number line. If you remember us doing opposites, all you do for an opposite is you change the sign. They are equal distances from 0. So whether it's a fraction, a decimal, whatever, you change the sign. So if we look at number 2, what are opposites of, and then they list out some numbers. So for positive 7, the opposite is negative 7. We change the sign. Negative 3.5 is positive 3.5. I guess I should do this in the darker color. And remember, if you have a positive number, you do not have to include the sign. We have a positive 2.25, so it becomes negative 2.25. And then we have a positive 9 1/3, so it becomes negative 9 1/3. Remember, opposites change the sign. So you change to the opposite sign. So I'm going to write that down to help you remember. Okay. So now we're going to go on to our next page. Absolute values. This is my favorite because absolute value is always positive. We learned this a few weeks ago. So you can also find the absolute value of a rational number the same way you find absolute value of an integer. You literally change the sign to positive no matter what it is. If it's already positive, it stays positive. If it's a negative, it goes to positive. If it's positive, it stays positive. If it's negative, it goes to positive. They're always, always, always positive. So I'm going to write that over here. Okay, I'm going to write it over here. Absolute value equals always positive. Please remember this. Remember how I said this is going to come up in future chapters? And here it is. All right, what is the absolute value of the average January low temperature in 2011? How do you know? Okay, so we have the year up here. The table shows the average low temperature in January in one location during a 5-year span. So all of these are in the month of January, and it tells us the year. Find the absolute value of the average January low temperature in 2009. So they did negative 5.4, so the absolute value is positive. They did that for us right there. They changed the sign. So now we have to do, what is the absolute value of the average January low temperature in 2011? So we have a positive 3.8. So I'm going to write my absolute value sign, which is the 2 brackets, equals 3.8. How do you know? It is the same distance from 0. Super easy. You keep it positive. Absolute value is always positive. So number 4, 5, 6, and 7. Graph each number on the number line. So the first thing is to graph each number. Then use your number line to find each absolute value. So first, we're just graphing the first number in each problem that they are giving us. So I'm underlining the first number. So let's look at number 4. So we see 0, negative 5, and positive 5. So to figure out what each little dash in our number line is, we have to count how many there are. So we have 0, 1, 2, 3, 4, 5. So we know from that each little dash is worth 1. So negative 4.5. So since it's negative, I go to the left. So I'm going to go 1, 2, 3, 4. And then that 0.5 is halfway between negative 4 and negative 5. So I graphed that, okay? Then we have to use the number line to find the absolute value. So all you do is you go the opposite way, the same number of spots. So it's a positive 4.5. You're really just counting how many units from 0 is it? Super easy. So then, number 5 is positive 1 1/2. So we go over 1, and then we have to go over halfway between 1 and 2. So, how many units was that? It was a positive 1 1/2. Remember, absolute value equals always positive. So I'm just going to put equal as a plus sign. And then we have a positive 4. That's super easy. We just count to the 4th one, which is right here. And then what's the absolute value of a positive 4? It is still positive 4 because it's 4 units away from 0 because it's 1, 2, 3, 4. All right, and our last one, negative 3 1/4. So we go negative 3, 1, 2, 3, and then 1/4. We just had to do this. It's tricky, but you want it closer to the 4 than halfway. So I tried. It looks a little bit closer. I'll try again so that you can really see that it's not at halfway. So it is a positive 3 1/4 because it just wants to know how many units. So up here when I did the negative for 4, when I went the opposite way, that was wrong. Miss Warnick had a brain fart. You're just counting the units. 1, 2, 3 1/2. It's 3 units. So it's positive 3 1/2 is the absolute value. All right, that was your homework for today, which is Monday. I hope this video helped you. We'll go over this tomorrow in our meet, and I'll go over any questions you might have.